How to verify a part which has been manufactured for the position control which has been applied on the GD&T drawing. So this is a GD&T drawing of a block which has 4 holes in a pattern. So how do we verify this GD&T control? This GD&T control which has been applied, how to verify it in an actual part? So one way of doing that is by setting an equation for each of the circles which are defined as tolerance zones. So the tolerance zones can have an analytical equation, and then we can input the values which are measured from the actual part in that equation and then verify whether it satisfies the condition or not. So if you are manufacturing a part with 4 holes as shown, and then we measure these 4 holes in their position with respect to the datums, and then we compare them with the equations which are derived for the tolerance zones, and if these coordinate values which have been measured satisfy these equations, then it is said to be acceptable. If they do not satisfy the equation, then it is unacceptable. The coordinate system which is used to establish the equation of the circles is established by the datums. So you can see over here, the coordinate system is established at the intersection of the 3 datums, that is datum A, datum B and datum C. So this is the point of intersection of all the 3 datums, and so this will be the origin, and hence the x-axis is over here and y-axis is on the vertical axis, x-axis is horizontal, and z-axis is through the plane of the screen. Now since we are finding the true position of these holes with respect to the coordinate system, we'll consider it to be a 2D analysis and not a 3D analysis. So for that we consider the perpendicularity variation of the axis. The perpendicularity variation of the axis is considered to be negligible as compared to the position variation. So this is an important assumption to make in this analysis. We are verifying only the position in 2D, which is the XY plane. So the equations for each tolerance zone for the 4 holes can be defined based on the equation of a circle in a coordinate axis system as shown over here. So here this is the x-axis, this is the y-axis. X-axis is horizontal, y-axis is vertical. So a circle which is having a radius r and which is having the coordinates of its center as h and k in the x and y axis respectively will have the equation in the analytical geometry form as x minus h the whole squared plus y minus k the whole squared is equal to r squared. So this is from basic math, basic geometry. We can get the equation of the circle in the coordinate system. H and k are the coordinates of the circle center in x and y respectively. So this is this value in the feature control frame 0.2, which is basically giving us the dia of the tolerance zone. So the dia of the tolerance zone is 0.2. So the condition for acceptance will be x minus h the whole square plus y minus k the whole square should be lesser than or equal to the radius of the tolerance zone the whole square, which is this r over here. So which is half of 0.2, which is 0.1 the whole square. So x minus h the whole square plus y minus k the whole square should be lesser than or equal to 0.1 squared. That is the condition for acceptance. Now let us form the equations for the tolerance zones for the 4 holes. So the coordinate system is shown over here. X-axis is horizontal, y-axis is vertical. So minus y-axis is towards downside and plus x-axis is towards right side, originating from the edge of the part over here. So consider this point as the edge of the part, which is the origin. So x plus x towards the right, minus y towards the downside. So with that and with the basic dimensions which are available in the drawing, which we can form the coordinates of the 4 points of center of the tolerance zones. So for this one is 20, minus 20, where x is 20 and y is minus 20. Here 100, minus 20, 20, minus 100, 100, minus 100. So any point which lies outside the tolerance zone is unacceptable. So any point which is lying outside the tolerance zone will basically create a circle which is having a radius which is higher than the value of the geometrical tolerance divided by 2. So that is how we find out whether it is acceptable or not, by finding the radius. If the radius is higher than the tolerance zone limit, then it is not acceptable. So let us form the equations for each of these holes. So for this hole, just substituting the value of h and k with respect to the coordinates over here. So in place of h it is 20, in place of k it is minus 20, substituting this value. Similarly doing the same for the other 3. We get the 4 equations